Okay, so we're going to talk about the present value formula. So this is the third and final video here, and the idea behind the present value formula is you want a certain amount of money in the future, okay, and you have a certain investment in mind that you're going to invest the money in, and you want the amount of that investment to be worth a certain amount, you know, let's say 10 years from now or whatever. And so the present value formula will actually give you the amount of money you need to invest right now in order to get that amount in the future. Okay? And it's really just a simple algebraic manipulation of the compound interest formula. Okay? So this is what it looks like. P is the principal that you have to invest right now, and it's equal to the amount that you want in the future divided by 1 plus r over n raised to the n times t. Okay, so basically all this stuff here down below is the stuff that's in the simple interest formula. And the simple interest formula is basically you take the principal times all of this in order to get the amount that you want in the future. And so you're kind of reversing it. You're taking the amount you want in the future, dividing it by all of that, in order to get the principal that you need to invest right now. So that's the idea. And as it turns out, this looks like super scary because you got a big complicated thing in the bottom of a fraction. But this is actually very easy. In fact, when you put it in your calculator, you put it in the exact same way as the compound interest formula, except for one button. There's one change, and you'll see what that is in a second. So this really isn't too bad. So let's do an example. Let's say I want to have $50,000 in the future. Let's say I just have a child that was born, and I want him to have $50,000 to help him when he goes to college. And I have an investment here. So I want $50,000, let's say in 18 years. And so now, how much do I need to invest now in an account that earns, let's say, 8.9% interest? We'll say compounded quarterly. So how much do I need to invest now in order to have $50,000 in 18 years in this particular account? Okay, well, the amount I need to invest now, that's P, is this amount, which is $50,000. And I'm going to divide that by all the stuff that's normally in the compound interest formula. 1 plus 0.089, and it's compounded quarterly, so that'll be 4. And I'm going to raise this to 4 times 18 for 18 years. So it looks like that, and that looks kind of scary, okay? But when I put it in my calculator, it really is just going to be the 50,000, and then I'm going to have divided by, and then in parentheses I'll have all this, 1 plus 0.089 divided by 4 raised to the 4 times 18. Okay, so this is exactly what you would put in for the compound interest formula, except for one keystroke, one button difference. Can you see what it is? It's that button right there. So in the compound interest formula, that would be multiplication. You would multiply. This would be like how much you invest multiplied by all of that. That would give you the amount that it was worth. So now you're going to take the amount that it was worth divided by all that, and that's going to give you the amount you need to invest. So let's see what it is. How much do I need to invest now for my child's education? Okay, 50,000 divided by, parentheses, 1 plus 0.089 divided by 4 raised to the 4 times 18. And I get, let's see, looks like I need $10,253.15. So that would need to be the amount that I would have to invest now in order to have $50,000 in 18 years. Okay, now normally people don't have this much to invest for their child's education, and so what people end up doing in real life is they end up putting a little bit away every every month into an account for so long in order to have the amount that they want in a certain amount of time. Okay, when you do that sort of thing, that's called a sinking fund, and there are other formulas that would tell you how much I would have to invest every month, for the next 10 years or whatever to get a certain amount for my child's education. Okay, and your book actually talks about some of those in, I think it's the section after mortgages, and annuities and sinking funds. Okay, which we're not going to do. You don't have to worry about that. Okay, so right now we're just, this general idea is how much you need to invest now to get a certain amount in the future. So let's just do 2 more quick examples, and I have them written out here. So let's say a combine cost $274,000. So how much would a farmer need to invest now at 7.2% interest, compounded daily? I forgot to put that in there. Compounded daily to get that amount in 5 years. Okay, so the amount they would need to invest now, P, would be the $274,000, and then you would have 1 plus 0.072 divided by 360 raised to the 360 times 5. Okay, so it's just like putting it in the compound interest formula, but you're dividing instead of multiplying at that one point. So 274,000 divided by, in the parentheses, 1 plus 0.072 divided by 360 raised to 360 times 5. And they would need $191,170.19. Okay, which is a little less than the $274,000. They'd save almost, they'd save over $80,000 by planning ahead a little bit. Okay, so and that's smart, because instead of paying interest on their combine, they would be earning interest, right? They're like twice ahead. Instead of paying out a little bit, they're earning a little bit. Okay, and that's a very wise thing to do. So this next one, just for fun, how much do you have to invest now at 11.2% interest compounded monthly to get $1 million in 35 years? So that's that, the interest rate you would need for like a retirement account or whatever. How much would I have to invest now to get $1 million in 35 years? Well, let's see. The amount I would invest now would be, you would take the $1 million that I want in 35 years, and then 1 plus 0.112 divided by 12, because it's compounded monthly, raised to the 12 times 35. Okay, and now let's put this into our calculator. So 1 million divided by 1 plus 0.112 divided by 12 raised to the 12, oops, I'm going to need a parentheses, ain't I? So raised to the 12 times 35 years. Okay, let's see how much it is. $2,020.51. Phenomenal. So you could have, you know what, I think I might have done the wrong thing. Darn it. You see what I did wrong here? I put 100,000. That's how much I would need for 100,000, right? I thought that was like not very much. I'm like, I'm going to invest money right there and hope I live another 35 years. Okay, let's do it again. Let's do it again. Okay. So, 1 million now. That's more like it. 1 plus point, and I think this was just going to add a 0 to this. But let's see. Let's make sure. 0.112 divided by 12 raised to, this will be 12 times 35. Yeah, added a 0. So that's $20,205.11. I was going to say, boy, I have $2,000. I could probably come up with that and invest it, but I don't have $20,000, unfortunately. Okay, but still, that's not very much in order to get $1 million, is it? And you know what's fun about this is you can play with this a little bit, right? I could edit this. Let me go back up. What if I invested it for 40 years? Okay, I'm probably not going to make it another 40 years, but a lot of you probably will. So if I invested for 40 years, I would need only 11,000. Wow, just 5 more years, and it almost cut that in half, didn't it? So let's try. What if I did 50 years? 50 years. Some of you might live another 50 years, very likely. How much is it? $3,795. Okay, so it's kind of fun. You can play around with this. This is the kind of the beginning of all of that sort of math that people that work in finance. This is the sort of math that they use. This is just the beginning of it. This is the tip of the iceberg, but this is where it all begins with the compound interest formula. So have fun with that.